very good morning to one and all. I am Sambangi Raju, pursuing graduation in GMR Institute of Technology, Rajam, which is located in Andhra Pradesh, India. And I am here to represent paper called Enhancing Remote Sensing Scene Classification with Channel and Spatial Attention using CNN. And my paper ID is 201, and I am one of the co-author of this paper. And our co-author is S. Akila Agnes, Bhargavi Pedada, and myself, Dasari Mohita, Vijay Prakash Penikonda, and Sairam Patil, and we are from Department of CSC. Let me tell you about my objective here. As you can see here, remote sensing gene classification plays a crucial role of analyzing Earth's surface through satellite or aerial imagery. The application of remote sensing gene classifications are vast, spanning using land use planning and urban development, environmental monitoring, disaster management, and all, etc. The complexity of the scenes remote sensing classification using image sensing or imaginary involving diverse backgrounds like vegetation, urban areas, and water bodies poses a challenging and accurately distinguishing using these elements. And using traditional CNNs often struggle to extract relevant features from high remote sensing images. So what we have done is we have developed our own sequential model using channel and spatial attention block. We have developed our own block using channel and spatial attention. So our traditional CNN is does not perform well on these images. So we have done our own sequential model using channel and spatial attention. So this novel model aims to improve classification and precision for remote sensing images by specific channels and spatial regions crucial identifying distinct scene features. So, to address this challenge, we have proposed our own innovative model called Channel and Spatial Attention Block, which is new to this CNN, which overcomes this challenge. Let me explain about the dataset here. We have used a dataset called RCNN7, which is a benchmark dataset in this research. The dataset is already available in the Kaggle website. We have downloaded this dataset from the Kaggle itself. It consists of seven class different categories like grass, field, industry, river, like forest, and residential, and so on. The entire dataset consists of 2,800 images, where with 400 class labels, where each class contains 400 images. So 7 into 4, 2,800 images overall. It is a high resolution images containing 256 of each category, 50 pixels, 56 pixels of each category. Let me explain about the proposed architecture here. As you can see, the input image is passed to these convolutional layers. For every convolutional layer, there is a block called attention block. So we have used these attention blocks. We are used four attention blocks here. Firstly, the image is passed through 3 by 3 convolutional block, and then it passes to the attention block. In the attention block, there are containing two operation. One is channel attention, one another one is spatial attention. Why we have used these blocks is in this channel attention and spatial attention, the attention means the we are here there is particular feature map where this attention can be used for. Here the attention in the sense it is particularly used in the image to extract the features of a particular region. As you can see here, and the max pooling and the average pooling are layer and the weights get multiplied to get the feature map, and the feature map is passed into the spatial attention block to get the extracted features, and then they might multiply to get more accuracy and more precision when compared to normal CNN. And you can see here, and there is for every attention layer there is a pooling layer which reduces the dimensionality of this uh, pooling layer itself. And lastly, we are using fully connected layers, which is used for the classification purpose, and we have used softmax function. And before softmax function, we have used a dropout layer, which drops 25% of the weights which are not assigned for. And finally, we get an output for the each class labels. So this is our proposed methodology where we have achieved the great accuracy for normal CNNs. Let me explain the model architecture here. The model architecture of CNN is a deep architecture integrates convolutional neural network with attention mechanism. In the layer itself, there are four convolutional layers using 3 by 3 kernel size here, and the four attention blocks using max pooling layers, and the classification block comprising two dense layers with 25% dropout. And as you can, and I have already said before, And let me tell you about the enhancements of traditional CNN. The initial CNN operates of 224 in the RCNN dataset, employing 32 filters and 3 by 3 filter size to generate the feature map. Attention integration represents a pivotal modification utilizing the feature map from the conventional layer in the attention layer. So the inclusion of the attention layer becomes the conventional layer to improve the performance of remote sensing scene classification. So the main intention of this model is to improve the performance of to overcome the challenge in the normal CNNs. Then the attention mechanism. There are two attention mechanisms we have used here: channel and spatial attention. The channel attention, in the sense, it is majorly focusing on the crucial channels within the feature map and identify the relevant features by computing average and maximum values along the channel and dimension here. Let me explain the spatial attention. It captures both global and local context information within the input feature map, and also utilizes global and average max pooling to aggregate spatial information. Here, in the spatial attention, we get the more accurate features from the image itself. Here, it is the mathematical notation for our proposed model. As you can see, channel attention for the mathematical function and the spatial attention for the mathematical function. By end of this, in the equation 3 itself, we are multiplying those two features from the map itself. We are getting the highly correlated features from these two blocks, and finally it passed into the channel. It finally passed into the dense layer to get classification. And the experimental setup here, the image is passed into the data pre-processing block where data splitting and data augmentation will be done here. And we have proposed the model. So model training will be, we have proposed many models. We have proposed Resnet 50, VGG19, VG19 with attention, VGG19 with normal attention, CNN with attention, CNN without attention, Resnet 50 with attention, Resnet 50 without attention. We have proposed the models over here. Model evaluation will be done here. Accuracy F1 score and recall that we will discuss in the earlier later. And the classification will be grass, field, river, and forest, and so on. So, and the tricks we are using precision, recall, subcode, and F1 score. Deep learning models such as CNN has been discussed here. We have used these models in this research over here. Let me explain about the performance analysis. See here, the rest with Restaurant 50 they got almost an accuracy 82, 67 and all. There is no bit difference when compared to Restaurant 50 with attention also. See over here to get more concentrated on the image itself. And compared to remote sensing scene classification with VGG19 and VGG19 with channel attention and spatial attention. See over here, you get an 80%, 88, 99 and all, but not good accuracy when compared to our proposed model. See, we have proposed this model. See, channel and spatial attention using CNN. We have built our own CNN model. We have incorporated this channel and spatial attention with our model. See, we got an accuracy about 99% over here, which we have achieved the great accuracy when compared to other models. With normal CNN, we got about 80, 40 and all. It's not bit complex when compared to this and all. Let me tell you about the conclusion over here. The performance analysis with various models. See here, with accuracy 84 with CNN, Raster 50, ND, and VG90 94. But with see here, when compared to CNN with channel and spatial attention, we got an accuracy about 96%, which we got an achieved a good accuracy here. When compared to conclusion, there are many challenges, their complexities in channel and spatial attention with our pattern and high resolution approach. You can see over here. But last conclusion is like channel and spatial CNN supervisivity. Let me tell you about it. Attains an impressive accuracy of 96% in remote sensing scene classification. The feature research innovators emphasize leveraging advanced attention mechanisms for enhanced remote sensing applications. Aim to particularly apply this mechanism to improve the performance of most exactly here. Exactly what we have done said is exactly, and these are our references. You can see over here we have the recent conferences we have took, and we have built our own sequential model. We achieved the great accuracy when compared to other these papers. So I finally conclude with we create thank you for thank you one and all. Thank you.